All right, here is our video going over the answer key for the review for chapter 3. So first, solve the systems of equations below. You may use the graphing, substitution, or elimination. Show your work. So looking at this, we could easily do substitution or elimination, but just from what I've seen in class, I think more people like elimination, so I'm going to show that method. So to do elimination, we can either get rid of the x or y. That doesn't matter. So let's get rid of the x just because it's out front there. So I'm going to multiply by -2 and then distribute that to every part of the problem. So -2x, -2y equals +4. Now I'm going to treat that like a giant addition problem. These cancel out. -5y equals -5. So we get y equals +1. So now that we have our y, we take that number and plug it back in to one of the equations. I think it's going to be easiest to plug it back in to this original equation up here. So x plus y, but we know y is 1, equals -2. Subtract that 1, -1, we get x equals -3. So our solution for this one is -3, 1. All right, now our word problem. A music student is selling tubs of cookie dough and bags of beef jerky for a fundraiser. Each tub of cookie dough sells for $15 and each bag of jerky sells for $10. The student sold a total of 15 items and earned $180. So first, we're always going to need to define our variables. So the first variable we've got here is the cookie dough. X is tubs of cookie dough. And then Y is going to be our beef jerky. Bags of beef jerky. So write a system of equations that models this situation. We're going to have two equations. So first we see these different dollar amounts, 15, 10, 180. Let's put all the money together into one equation. So cookie dough is the $15, so 15x plus 10y equals 180. And remember, this first page, we're doing equations, so equal signs, not greater than or less than signs. The other thing we know is that the student sold 15 items. So the tubs of cookie dough plus the tubs of beef or bags of beef jerky is going to have to equal 15. So just plain x plus y equals the 15 items they sold. All right, now how many tubs of cookie dough or bags of beef jerky were sold? Well, now we're kind of at where we were with question 1. We have two equations and we just need to solve for the solution, the point where they intersect. So once again, I think this is one where a lot of people are going to like the elimination. Looking at this, if I do 15, I'm going to end up with negative numbers. So I'm going to get rid of the y this time. I'm going to do -10. So distribute that -10. We get -10x plus -10y equals -150. Then I'm just going to rewrite the other one. 15x plus 10y equals 180. Giant addition problem. The y's cancel out. We have 5x equals 30. So x equals 6. So now x equals 6, and we know that x plus y is 15. So 6 is our x plus y equals 15. Subtract the 6, we get y equals 9. Remember, for these questions where they're asking for your final answer, I would like you to write a full sentence giving your answer. The student sold 6 tubs of cookie dough and 9 bags of jerky. Okay. All right, there's the first page. So moving on to the next page, graph the system of inequalities. So here we're going to graph our 2 lines and do the shading. So both of these are actually going to work pretty well for the cover-up method. So that's what I'm going to use. That's what I tend to use. So if I cover up x, 2y is less than 2, solve for y equals 1. Then if I cover up y, x equals 2. So y is 1, x is 2, and then we're going to connect those points. I see the slope. I'm just going to put a couple more points in there to try and get my line nice and straight. And then, is this going to be a dotted or solid line? Looking at the inequality, it is underlined, so it is going to be a solid line. And then decide where to shade. So like I've said before, when we use the cover-up method, when the x and y are on the same side, we can't just say less than is below and greater than is above. We need to check a point. I always check 0, 0. So if I plug that 0 in, I get the whole left side goes to 0, less than or equal to 2. So then check, is 0 less than 2? Yes. So we're going to shade where the 0 is because we got a true statement. All right, so now the other line. X plus y is greater than 0. So when we do the cover-up method for this one, they're both going to equal 0. So if I covered up the x, y is 0. Cover up the y, x is 0. So unfortunately, I mean, we know there's going to be the point here at 0, 0, but the cover-up method doesn't really work. I'm going to have to solve for y. Y is greater than, I'm going to have to subtract that x over, and then you could write the plus 0, that's fine. But either way, it is negative x. So my slope is negative 1, so I'm going to go down 1 over 1, down 1 over 1. I'm going to go backwards a little bit. And then this one is actually a dotted line. So I'm just going to keep making points and use that as my dotted line. So there we go. There's my dotted line. Arrows. And then we need to decide where to shade. So y is greater than negative x. Greater than means we are going to shade above. So this little region right here is my solution. Okay, just one more left. All right, Jamboree makes rings and pendants. Each week, the staff uses at most 100 grams of metal. It takes 10 grams of metal to make a ring and 20 grams to make a pendant. Each week, the staff spends 90 hours making jewelry. Each ring takes 1.5 hours, and each pendant takes 1 hour. So, define your variables. X, I'm going to do rings, number of rings. Y, I'm going to do pendants. and then write two equations. So they actually have it broken up really nicely for us. The first one talks about metal, the second one talks about hours. So we're going to have one equation from each of those numbers up above that match right below. So number one, talking about metal, 10 grams for the ring, so 10x, plus 20 grams for the pendant, and it uses at most 1,000 grams. So less than or equal to 1,000. All right, and then hours. 1.5 hours plus 1 hour. Oh, I just realized up above I had two x's. That should have been 20y. So 1.5x for the hours now, plus 1 hour for the pendants, 1y, has to be less than or equal to 90. All right, and then these are both actually okay, at least the first one. Let's do the first one using that cover-up method again. So x equals 100. So x equals 100 is at the very end of our graph. Y equals, I believe, let me check this, 50. 1,000 divided by 20, yep, is 50. And they're both going to be solid lines, so I'm going to connect these in a solid line. And then if we make the whole left side equal to 0, so x and y both become 0, 0 is less than 1,000, that is a true statement. So I'm going to shade below where the 0 is. Actually, I don't like the overlap. Okay. And then our other one actually works really well for the cover-up method again. So I'm going to do that one. So if I cover up the x, well, y just equals 1, or sorry, y equals 90. And then if I cover up the y, x equals 60. So x equals 60. Connect those two dots. And then once again, if the whole left side, if this whole side becomes 0, 0 is less than 90, that is a true statement. So I'm going to shade this region. And this area right here, between these two lines, this area is my solution. So we did part C, we graphed it. Now, part D, find two possible combinations of rings and pendants. Well, you can pick any 2 points. I mean, there are a lot of points in here. You can even pick one on the edge because they're solid lines. So just pick any 2 points, and that is your answer for D. So yeah, I'm going to say this one on the edge. I'm going to say 40, 30. And then how about this one? 30, 20. All right, there it is. Let me know if you have any more questions. Thanks.